Okay, example 3, same as the first two. Again, make sure you're watching out for those missing terms. So we've got x to the third. There are no x squared terms, so we're going to say plus 0x squared minus 3x plus 5. And we're going to divide by x plus 2. So using our coefficients, we got 1, 0, negative 3, positive 5. And in the box, again, we're putting the 0 of our divisors, so the 0 of x plus 2, so we'll do negative 2. Repeating that process we've been doing, so drop the first one. 1 times that negative 2 in the box is negative 2. 0 plus negative 2 is negative 2. Negative 2 times the negative 2 in the box is positive 4. Negative 3 plus positive 4 is positive 1. We're going to take that, multiply that by negative 2, giving us negative 2. And then 5 plus negative 2, or minus 2, is 3. And there's our remainder. And so we started with x to the third. We always drop down 1 degree when we're doing synthetic division. So we end up with 1x to the second minus 2x plus 1. And again, we'll put our remainder over our original divisor of x plus 2. Now the bottom part of this says also now plug in negative 2 into the original dividend. So plugging that back into the original, negative 2 to the third minus 3 times negative 2 plus 5. Cleaning that up a little bit, negative 2 to the third is negative 8. Remember to put that in parentheses. Minus 3 times negative 2, in other words, plus 6 plus 5. So negative 8 plus 6 is negative 2 plus 5 is 3. 3. We'll come back to that. Example 4. Dividing one more time. X to the third minus 2x squared minus 4x plus 9. We are not missing any terms, so we're just going to write our coefficients. 1, negative 2, negative 4, positive 9. And in the box, what do you think we should put? Oh, that's right, you're not here to respond to me. We're going to put a positive 3. So the 0 of our divisor. So, as per usual, we're going to drop that first number down. So 1 times that 3 in the box, we get 3. Negative 2 plus 3 is 1. 1 times 3 is 3. Negative 4 plus 3 is negative 1. 3 times negative 1 is negative 3. 9 plus negative 3 is 6. And that's our remainder. So again, we start off with x to the third, dividing by x. We're going to end up with x squared plus x minus 1. So these three things all end up being negatives, or end up being something with a 1, plus our remainder over our original divisor of x minus 3. Now the bottom part says the same thing as we did in the previous page, this time plugging in 3. So we're asked to plug in 3 into the original divisor, the original dividend. So we got 3 to the third minus 2 times 3 squared minus 4 times 3 plus 9. 3 cubed, 27. 2 times 3 squared, well 3 squared is 9, so 2 times 3 squared, or 2 times 9 is negative 18. 4 times 3, so we got minus 12, and then plus 9. 27 minus 18 is 9, minus 12 is negative 3, plus 9 is 6. That looks familiar. Wait, let's go back a second. Looking back at that number we got at the bottom here, we got the number 3. Where else in this problem did we see 3? That was our remainder. Looking at example 4. When we plugged in that 3, we got a 6, which, hey, that was our remainder. Folks, this is the remainder theorem. Let's take a look at the official wording for the remainder theorem. So the remainder theorem says if the polynomial p of x is divided by x minus a, then the remainder is r, or the remainder r is p of a. In other words, what happens when you plug in that value a? So taking a look at their example here, x to the third minus 4x squared plus 5x plus 1, dividing that by x minus 3. They did synthetic division. They plugged in that 3 into that box. They went through, did the whole process and get a remainder 7. They also could have done it by plugging in the 3 into the original equation. So they do 3 cubed minus 4 times 3 squared plus 5 times 3 plus 1, and that all simplifies down to 7. So if you want to check to see if there is a remainder and what the remainder should be, plug the 0 of your divisor into your polynomial. And that's all.